Welcome back. This is the video on this series for this mini lathe, Vevor mini lathe 8 by 16. In this video, I'm going to be cleaning up the saddle and I will present it to the bed to see how much gap it is present, and also if I can measure there is any rocking or instability on the saddle. Let's continue with the saddle and remove the handle. And this is the dial. And this is the screw, and it's all disassembled now. Now let's proceed to clean it with W40, and then we can continue. Now that everything is clean, I can show you what is my theory. So here we have this triangular shape. If the saddle sit on this rail, in order to make 100% contact here on this V, it has to be this way. So this surface has to be parallel to the bed. So we are going to measure how much of a shim I have to include here to make the saddle to be at the same angle that this bed. If I zero the dial indicator, so we have here and we start going down, we have over here we already have 1 millimeter of difference going that way. Here I have two shims. This is 88 millimeters and 30 millimeters. So let's see what happens if we put it in that part. And here we have the indicator on 0. Then we start moving it. Just increase a little bit. But then it goes back to close to 0 again. And that one was 88 plus 18, 0.88 plus 0.18 millimeters shim. So it's 1.16 millimeters shim that I need for if I want to put the saddle perpendicular to the bed and improve the surface contacts on this V-shaped rail. I'm going to deboard these edges with this triangular shape. a comment on my theory that the saddle has to be perpendicular to the bed waist. The only way to prove that one is with blue ink and then see the impression of that blue ink into the saddle and see if the contact is making 100% contact or is only in one spot or two spot. And then I had to go with a scraper and scrap all the parts that are high on the surface contact, and then I can guarantee that I have improved the surface contact. But since I don't have all that equipment, I want to first assemble the lathe and see how is the performance without doing any modifications. I'm going to start the assembly process, and for that I will need oil. So in this case I'm using this whey oil. I bought it on eBay. And for the oiler I'm going to use this cute oiler one. And we are ready to start oiling. I'm going to start assembling the saddle again. So here we have to put a little bit of oil. Okay, I got a little confused, but I think that this part goes here first. And then this part goes here. And what I have seen people putting is inside here, they put a washer to avoid to correct the backlash. This part here that move, this should not be moving. Way better. Now we have the saddle ready again. Now we can proceed to adjust the saddle in the bed. Let's put a little bit of oil. And this tip is like not for this job. Oh, it's not putting the oil inside. Oh no, it's putting it. Yep, it is. It's a really dirty oil. Okay, there is no rocking here. If I put also, if I try to move it this way, I don't see a lot of play. That is good. Here, of course, I had to secure this one on the bottom, but without any adjustment, it's sitting well. There is no play. That is good. Let me now to start tightening those bolts and see how it goes. I just adjust this bolts here with my fingers to feel how much I was tightening it and to not over tighten it. And it's moving here. It's a little bit harder to move over here, but here is moving right. There is no movement in this way on the Z-axis. This way, but in the Z-axis rotation, I feel just a little bit, but it's difficult to move it. So I think it's well adjusted and it's going to do well. I will continue with the assembly of the headstock. Next, I'm going to assemble this one loosely, and then when the apron comes, I'm going to secure it. Now these two connectors goes here in each one of this one. Okay, here we go. Now there. And this sensor goes here. There is something that is not concentric here with these gears. It's becoming okay, it's working. Something that I am really happy is if I put the indicator here and I try to move this part here, it's only moved like 300ths of a millimeters. It's not that big of 3 or 4 difference. And if I try to rotate the saddle on the Z-axis, then the movement that I have is 1, 2, 3, 6, 7 difference. Yeah, that one is a little bit bigger than the other one. But overall, I'm happy with these tolerances. I had to see how the finishes goes when I do the first chips on this lathe. Now it's time to clean up the apron. Has a little bit of rust. All these ones are, I don't know if it's rust. Yeah, I think it's rust. A little bit. Yeah, that way. Remove all that. I can see some high spots here getting removed with this file. Okay, here is just a little complicated. Goes like this. Then this one goes like this. Okay, we have it right there. And then we move this piece over here. And we connect these ones. Okay. Then we had to do the final adjustments for the lead screw. The way of adjusting the lead screw is the following. You move the saddle to the end here and you lock it. When you lock it, then you can tie these screws. And then next step, you put loose these screws here at the beginning. You move the saddle or the carriage to the front, and then you lock the lead screw again. And then you tie the screws on the lead screw. And that way is adjusted. Next, we have to install this panel. And assembly back the control panel. Have to adjust this gear. To engage here. Here we can start cleaning the base of the cross slide. This really was dirty. Color all that. Now it's time to assemble the cross light. Let's see if these things align here. Yeah, a little bit. First, we adjust the screw on the middle. We measure the tension that we want. And then we tie this knot here. Okay. And then we start tying up the other ones. So feel the same tension. And we tie these nuts. We lock this one here and then we tie the knot. This part here is really rough, so we have to deburr it. It is time now to put the tool post. First this spring, then this pin, and then the tool post. Now this is one of the most important tests. So here I have an indicator set up and I'm going to apply forces back and forth and see what is the movement of the tool post under forces. So in here, okay, we have 10, 100 of millimeter. 10, 15 if I apply a lot of force. So 15 in one direction, 15 in another direction. 10, 15. Yeah, I think that's really amazing. I have seen other videos on YouTube where they have 50, like half of a millimeter. I think 15, or let's see again, 20, 0 here. If I push it over there, I can set 20, and I'm doing a lot of force. And then 80 here. Yeah. So I'm really happy with that measure, man. I mean, it's not super tight, but it also is not bad. And with respect with the other issues that I was having, I'm really happy that this end up like this measurement here, and I don't have too much play here. I had to really like crank this thing to put it on 20. So additionally, moving the carriage back and forth feels butter smooth, and at the same time is super solid. I love it. Here is the laid back, totally assembly. I put the backsplash and this side cover. So and the tailstock. The tailstock I have not touched it because I can disassemble and detach it. So that will be another video, how to center this one with the headstock. But I'm really happy with the results that I got so far. When I put the indicator and then I was pushing this, the displacement was not that much, only like 10 to 20. And in 20, I was applying a lot of force. I was cracking myself here to move it. So I'm really happy with that. And this is the end of this video. Thank you for tuning in. And please hit the bell notification so you will get notified when the next video for the quick change tool post is ready. And until there, I see you on the next one. Thank you.